Hello guys, my name is Engineer Halidi. We want to solve questions on the refraction through prism triangle. Let's start with the rectangular prism. And in this case, for us to analyze any questions, we want to look at all possible kind of questions they can ask us for a rectangular prism. The question one says, which of the following conditions must be satisfied for total internal reflection to occur? Roman figure 1, light must travel from a denser medium to a less dense medium. I think that one is clear and that one is correct. Because for total internal reflection to occur, light must travel from a higher density material or medium to a lower density medium. Just like we were traveling, light traveling from water to glass, or from air, water to air, or from oil to air, or from glass to oil, or from glass to water. These are possible what movement of light to produce a total internal reflection. Roman figure 2 says angle of incident must be equal to angle must be equal to critical angle. No, angle of incident must be greater or exceed the greater critical angle. If I have a prism like this, a rough sketch, this is a rectangular prism. Let me have a normal and let me have an angle of incident like this. Now, if it's at critical stage, the refraction will be at the surface, the boundary surface between the glass and the air. This is the glass and this is the air. So at this point, we say this incident angle is what we call the critical angle. And to find it, it's equal to n equal to sine c. Now don't forget it was from sine I over sine r that will get it as n. Also remember that if you have air to glass formula is what? Sine theta in air over sine theta in glass. So sine theta in air is 90, which is 1, and sine theta in glass is c, sine c. Then theta in glass is critical angle at this point. So air to glass is what is particularly what defined as this formula. Now, having known that now, but if you exceed this critical angle, maybe you take it a little, increase the incident angle a little bit, you will notice that the reflection, this particular what you call it, the refraction at the surface will now be sent back into the glass at a reflected angle, meaning that the angle of refraction is now greater than 90. Does that mean Snell's law does not obey? No, it obeys. It's still valid. So what I will go for is that I'll go for angle of refraction must be at right angle. No. Angle of incident must exceed the critical angle. Yes. So 1 and 4 is correct here. Now Snell's law becomes invalid, wrong. So this statement is wrong. This statement is also wrong, and this method is wrong. So I'll go with 1 and 4, and there's no 1 and 4 there. What we only have is 1, 4, 5. So I'll go with none of the above. Number 2. Given that the refractive index of glass is what? That means we are giving glass to be what? 1.5. And that of air is what? The air is what? Equal to what? 1.33. Okay? They said what? And that of air to water, rather. Air to water sorry, is air to water. So now that of what? Glass to then when I say want to find the that of glass to water. Now what we want to solve now for us to find glass to water, it simply means that what? NW over NG. Now don't forget that the refractive index of 1 to 2, e.g. air to glass, is equal to what? Ng over Na. That means it should not be 2 over 1. So in that case now, since we are looking for glass to water, find that of glass to water. It's now be what? N water, refractive index of water over refractive index of what? Of glass. So what we want to do now is what? Refractive index of air to water over refractive index of air to glass will now be equals to what? 1.33 divided by what? 1.50. So if you divide it, you are supposed to have an answer that will be equal to what? By 1.33 divided by 1.50. So our answer becomes what? 0.88, which is approximately what? 0.89 as your answer. So C will be your answer there. The next question now says, an object is placed at the bottom of a glass 16 centimeter thick. So what we are going to have now, let's say at the bottom of a glass block. Let's say this is a glass block. This is a glass block. It is 16 centimeter thick. And it's placed what? That means an object placed at the bottom of the glass block 16 centimeter thick. That means maybe somewhere here. Let's say this is normal. So let's say this. Now let's say this is the object. But instead of that, it will now what? Appear here. You understand? Now what they say we should look for now? They said thick is displayed 4 centimeter upwards. You understand? A glass of 16 centimeter thick is displayed 4 centimeter upward. That means from here to this place is 4 centimeter upward. From down to up, that means from down, move up 4 centimeter. That means from here to this place is what? 12 centimeter. So don't forget, 12 centimeter is what we call the apparent depth. While 4 centimeter is what? The displacement now. Now, having known that now, what we want to do now is that we can now use our what? Now, don't forget, see if the angle of refraction of the ray from the object into the air is 40, calculate the angle of what? Incident. If the angle of refraction of ray from the object into the air is what? Now, from the object into the air. So that means refraction is given as is 40 degrees. This is the object now into the air. Now refraction is 40. So if angle of refraction is 40 degrees, then what is angle of incident? That's what we are looking for. So if I want to do this now, what I will just do simply is to what? Use my n equals to what? Read depth divided by what? The apparent depth equal to what? Sine I over sine R. Now, if you want to use this formula, real depth is 16. Don't forget, apparent depth is what? C minus D. If everything here is T, and here is displacement from here to here. So that means from here like this to this place is what? T minus D. So please take note of that. So 16 divided by apparent depth is what? 12 equal to what? Sine I over what? Sine 40 degree. So what I want to do now is to make I the solid of 1. So sine I equal to this sine 40 multiplied by 16 divided by 12. So what do we have? We have 16 times sine 40 will give us what? 10.2 divided by 12 will give us 8.0.857. Now, I will now be equal to what? Sine inverse of this will give us what? What is sine inverse of that? Answer 58.98. So the answer is 58.98 degree. So that's our answer for that question. So please take note that, go through these questions and what, and learn from it. So that is just that. That is in the next question, number 4. It said calculate the approximate value of the critical angle when light travel from material of refractive index N is what? 1.54. We are looking for critical angle unknown and travel from a material of refractive index this. That means to a material of refractive index this. So this is a first material, let's say 2. It now travel to another material 2, 1 to what? 1.33. So it's traveling from air. So that means let's say start from 1 to 2 will now give us 1 over sine C. But if you want to use 2 to 1, 2 to 1 will be equal to what? Sine C over 1. Please don't forget that when a material travels from air, check the formula, air to glass is equal to 1 over sine C. That means from a lesser medium to a denser medium is 1 over sine C. If you check, how do you know a denser medium? A denser medium is a medium with higher refractive index, while a less dense medium is a medium with lesser refractive index. The air has a lesser refractive index. So if I move from glass to air, I will have a critical angle in the glass to be sine C. As simple as that. So now, if you don't want to use that formula, you can use what? N2 sine theta 2 equal to N1 sine theta 1. Now, this one has a higher refractive index, which is 1.54. This one have 1.33. That means this one is lesser, is less dense. Now, or this one is what? Denser, medium. So if that is denser medium, it means that this one is what? 1.54 times sine C. Because the critical angle will always be in the denser medium. Equal to what? 1.33 times what? Sine 90. Because at critical angle, the refracted angle, which is the angle at the less dense medium, is 90 degrees. between the boundary of glass and air. And let's solve. So what do we do now to get our final answer? You divide both sides by what? 1.54. This we cancel this, eliminate that one. So what do we have? Don't forget that I told you that the critical angle C occurs at the denser medium. And C that is at what occurs at denser medium is, you can notice them by their value of refractive index higher. Their refractive index must be higher than the less dense medium refractive index, so that you can have the right answer. So this one now give us what? 1.33 times 9 sine 90 is 1 divided by 1.54. So that means that 1.33 divided by 1 because sine 90 is what? Is 1. It gives us 19/22. Then check the sine inverse of that. Another 59 point what? 0.7. 59.7. That is your B answer. So in case now, and this is what? Sine inverse. Sorry for that. This one give us what? Sine inverse of C. Because everything you have here will now be what? Sine C is equal to what? 1.33 divided by 1.5. 1.54. So 0.863 again, 63 and all that. So that is just that. So if you now take sine inverse of that, what we want to have is what? Sine inverse of 0.863636 and so forth and so on. We want to have approximately 59.7 degree as your C. So that will be your answer to that question. So please go through it and comprehend it well. Number 5, a glass plate of thickness. The thickness of the glass plate is what? Thickness is 0.6 centimeter. As a refractive index, N is given as what? Which is refractive index is equal to 1.55. Calculate the time taken for a ray of light to pass through it. We are giving C as for speed of light as 3 times 10⁸ meter per second. Now this one, if you convert it to meter, you are going to have what? 0.6 times 10⁻² meter, because centi is 10⁻², micro 10⁻6, nano 10⁻9, pico 10⁻12, and so forth and so on. Then milli is 10⁻3, centi is what? 10⁻². So you are going to have it as what? 6 times 10⁻³ meter. Now, having gotten that now, what you're going to do now is to use our formula N equal to C, speed of light in air, over this. So this one is what? Speed of light in air divided by what? Speed of light in a medium. So if you can do that now, what we're going to do now is to what? For speed of light in the medium will now be what? Thickness divided by what? Time. So the speed of light in air will now be what? This is what? Speed of light in a medium, which is thickness over time is the speed of light. You can calculate speed of light in a medium by using that formula, which is simply as what? The time we go up as what? C times what? Time divided by what? Thickness. So what I will now do is to what? Our n is 1.55 is equal to 3 times 10 raised by 8 times time divided by what? Thickness is what? 6 times 10 raised by minus 3. So if you cross multiply now, this go for this one go for this. I'm going to have it as what? 1.55 times 6 times 10 raised by minus 3 equal to what? 3 times 10 raised by 8 times time. Now making time stand alone, divide both sides by 3 times 10 raised by 8. So that we can make that what is subject, the time isolator formula. This one we cancel this. So what we are left with now will now be 1.55 times 6 times 10 raised by minus 3 divided by what? By 3 times 10 raised by what? 8. We are going to have 3.1 times 10 raised by minus 11. 3.1 times 10 raised by what? Minus 11 seconds. So this is what we are going to have as our answer. Okay, I think the answer is there. You understand? The answer is there. Now, for that number 4, some people might be confused that which answer should we choose for number 4. Number 4, the answer, you can go with 60 degree for number 4. So you go with C. If you are giving, if you don't see your 60 degrees, then you go for none of the above. For number 3, I think we had a 58.9. You go for none of the above. Go for none of the above. Take note of that. Let's go to number 6. You say the wavelength of red light from human helium neon laser. The wavelength of red light from helium neon laser is 633 nanometer in air, but 474 nanometer in an aqueous room inside the eyeball. Calculate the refractive index of the aqueous room and the speed and the frequency of light in the substance. Now, refractive index is what? Wavelength of light in air over wavelength of light in a medium. So in this case now, they say the wavelength of red light of helium neon laser is this in air. So 633 divided by what? And 474 in aqueous room inside the eyeball. So 474 nanometer, no, so no unit. They'll cancel out. So if you divide what? 633 divided by 474, what we're going to have supposed to be 1.335. 1.335. Approximately what? 1.34. Then, but they now say we have calculated refractive index. Now, what did they now say? They say we should find, excuse me, calculate the what? The speed. So, N is also the same as speed of light in air over speed of light in a medium. So, we already have our refractive index. So, we use 1.335 is equal to what? 3 times 10 by 8 divided by speed of light in a medium. So what we're going to have now is to cross multiply. So we're going to have what? In a medium becomes what? 3 times 10 raised by 8 divided by 1.335. If you cross multiply and make this one generator formula. So what we're going to have now will now be equal to what? 3 times 10 raised by 8 divided by 1.335. I think our answer should be equal to what? 222. 224719101.1. So that is what 224719101.1 is about what 1, 2, 3, 4, 5, 6, 7, 8. That is about 2.247 times 10 to the power 8. So that is about approximately what 2.25 times 10 to the power 8 meter per second. So please take note of that to make sure that you get your answer. You have to be careful of the approximation. Let's go to number 7. Number 7 says water of N equal to what? 1.33 in a glass container of 1.52. If the incident ray makes an angle of 60 degrees with the normal, find the direction of the reflected ray. Find the direction of the reflected ray. Now the question was corrected because this is refracted ray, not reflected ray. Now they said what water of N equal to 1.33 in a glass container of N 1.52. If the incident ray makes an angle of 60 degrees with the normal, then find the direction of the refracted ray. So that means that if you have a what? A container. Now that container now has a what? A glass inside. Or in a glass container. Now have water rather. So there's water in a glass container. So this is a glass container. What we notice is that the N of water is 1.33. N of glass is equal to what? 1.52. So that means that what? The theta in water is equal to what? 60 degrees. So we are looking for theta in glass. That's what we are looking for. So if you check very well, you will notice that what is missing here is theta in glass. So what I want to do now is that theta in glass is a refraction. Because look at the normal here, this 60 degrees. Then this is the glass. This is water, the glass container. So in that case now, what I want to do now is use what? N water sine theta water equal to N glass sine theta glass. So sine theta glass now is our what? Refracted angle. The direction of the refracted ray is refracted angle. Direction out of which angle? So in that case now, what we want to do now is what? 1.533 rather sine 60 equal to what? The theta in glass is what? This is for glass. 1.52 sine theta in glass. Remember, say if the incident ray makes an angle of what? Of 60 degrees with the normal. So the water is lesser. That means it's coming from a less dense medium, and it will not enter the denser medium, which is less dense medium, to a denser medium. So more or less like water will float in the glass. Glass will go down. So if you're going to have an incident and it is the water you will meet first before the water, that means incident will be made on the water before it now enter the glass, because glass is denser, so it will be below, while water is less dense, it will be above. So in that case, theta in glass should be equal to what? Divide both sides by what? That be what? 1.33 sine 60 divided by 1.52. So if you do that, what we are going to have is what? I would have 0.758. Let's check. 1.33 sine 60 degree divided by 1.52. So 0.758. So if you now look for that is sine theta in glass. So theta in glass will now be what? Sine inverse of what? 0.758. Approximately we are going to be having what? 49.3 degree. So that's what I want to have for the answer for that question. Number 8, it says what? If the ray of light is incident on glass boundary at 30 degree, find the incident angle in the glass. So we know that n water sine theta in water equal to n glass sine theta in glass. You don't know it now. Now this can be incident angle in what? In water, can be incident angle in glass. So what I want to do is simply what? Just put your parameter 4/3 times what is incident angle in water. We are going to have sine 30 is equals to, what about in glass is what? 3/2 times sine theta in glass. That is incident angle in glass. So what I want to do now is to divide both sides by what? 3/2. This one will cancel this. So we have sine theta in glass equal to what? What do we have? It becomes what? 4 divided by 3 is equal to 1.33 times sine 30 divided by what? Divide by what? 3/2. Then check what sine inverse of whatever answer we are going to have. So the answer, first of all, before we go further, the answer is what? 4/9. So theta g will now be what? Sine inverse of what? 4/9. So that will give us what? Sine inverse of 4/9 give us 26.38. 26.38. So that is incident angle 387. So that means about 26.39 degree. So that is incident angle in glass. So let's go to number 9. Number 9 says, what is the refractive index of material of a critical angle of light passing from a material to air? What is the refractive index of a material critical angle of light passing from the material to air? So what we are looking for is refractive index. What is a refractive index? So of a material critical angle of light passing from that is this. So that means this is a critical angle. So we are looking for what? This critical angle is what? 24.4. So we put it there. To find the refractive index, that will be what? 1/sine 24.4. And that will give us our answer for that. 1 divided by sine 24.4. So that will give us 2.42. 2.42 as our answer, no unit. The next one says a layer of oil floats in water. A layer of oil 1.40 float in water. So that means this is the water, this is the oil. For something to float means it's on top. Floating is oil. This is water. And this is the air. This is float in water, on water 1.33. A ray of light shine onto the oil. So that means when the ray of light shine onto the oil with an incident now we notice that some little problem with that question, so we have to correct it, because now they have given us, they said what, a layer of oil floats on water. That means what, this is oil of 1.45. They now said float water of, what is the n here, 1.33. So this n of oil, n of water. So now they now say find the angle. That means they say a ray of light shine onto the oil with an angle of 40 degrees. Find the angle the ray makes in the water. Now, first of all, it's coming from air. It will now refract toward through the oil, then down to water. So this is the step it will take. So from air to oil, this one is oil, theta what? Oil, then to water. This one will not be what? Theta in water. So now let's take it one after the other. Let's start with what, from air to oil. So that means n air sine theta in air equal to n water sine theta, n oil sine theta in oil. Let's start with that one first. So now, if you solve that one, if you now know the angle, don't forget this angle will be alternate to this angle. This angle here is alternate to this angle. So automatically mean that if you can get here, we have got here. So it will be easy for us to get here. So I'm going to have what? N air is 1.00 sine theta in air is what? 40 equal to what? N oil is 1.45 sine theta in oil. So what I want to do now is to make oil. So if you make oil the subject of formula, sine theta in oil, what I want to have is what? To make this one the subject of formula, the variables are 1.45. I would have 1.00 sine 40 divided by 1.45. So now, if you do that, I want to have it as what? Then take what? Theta in oil now will now be what? Theta in oil will now be what? Sine inverse of what? Whatever we have here. 1 times what? 1 times sine 40 divided by 1.45. So sine inverse of it will give us what? Our final answer, which is what? 26.31. That is not our final answer. Sine 40 divided by 1.45. Sine inverse. So that will give us what? 26.31. This theta in oil. Now, having done that, now we are now going to go to n in water, sine theta in water, go to n in oil, sine theta in oil. Don't forget that the incident angle in oil now is now what? 26.31. So we have the refractive index of oil. So we are looking for what? The angle in water, which is this theta W. So sine theta W becomes what? N oil times sine theta oil divided by what? N water. So if you do that now, what do you have? 1.45 times sine 26.31 divided by what? 26.31 divided by what? 1.33. So what I want to have now is what? The answer times 1.45 divided by what? 1.33. So what we are seeing is that sine 26.31 rather times 1.45 divided by 1.33. So I want to have it as what? Sine theta W equal to 0.483218. So when you find the sine inverse of this answer, 0.48, to get theta W now. So 3218. What do you have? What will be our final answers? So sine inverse of the answer was 28.89. 28.89. If you don't go and choose 28.8, rather you go for what? 28.9 degree. Because 28.9 degree is, this one is up to more than 5, or from 5 and above. You take it to 8, become 28.9. So now we want to enter another dimension of questions now. Please enjoy this question and let's see what we can do. Now this one says the speed of light in water is 75% of what? Speed of light in air. What is the effect on frequency and other? Don't forget that there was a question I did not solve. I think that was number 6, because they were asking of what? Frequency. And I did not solve it because in refraction, frequency does not change. During refraction, frequency does not change. You check question number 6. Check where they ask us what? The frequency of light in the substance when we're talking about helium, neon, laser. I did not solve it. Why? Because the frequency will remain the same. The same thing with this one now. The effect of frequency, no frequency will not change. When light travels from a lesser medium or from one medium to another, the frequency remains the same. What changes is wavelength and speed. Now, let's go. So, the speed of light in water is 75% of the speed in a vacuum. What is the effect of frequency and the wavelength of light passing from vacuum or air into water? Now, what the wavelength will change, but the frequency will not change when it's going from air to water. But let's solve the refractive index. Now, we have what is the refractive index is what? Speed of light in air divided by what? Speed of light in a medium. So the speed of light in water is what? What this is 75% of what? C. While the speed of light in air is C. So how do we get our n? So our n will now be what? 75% is same thing as what? You can say this one will cancel. Okay, before I cancel, let me not cancel it first. So what I want to do now is that let me convert the 75% to what? To decimal. Now it was 0.75 times C. So C we cancel C. So what do we have now? C is the speed of light in air. Don't forget, C is 3 times 10 to the power meter per second. So we are going to have 1 divided by 0.75, like 4/3, which is 1.33 approximately. Consider a film of oil. Film. Consider a film of oil of thickness 8 centimeter and refractive index 1.48, floating on top of water. So a flint of oil is flint of oil, a film of oil rather. Thickness, what is the thickness of this? 8 centimeter. And what is refractive index? 1.48. Floating on top of water. This water, this oil, water. What is water thickness? Don't mind my length. We are not using meter now or ruler rather, so that you can measure it. So it's just assumptions. So water, the refractive index of this one is 1.33. Now, on top of glass block, this one is not glass block. Glass block. What is it? What length of the glass block is 10 centimeter. On top of the glass block with refractive index of what? Is water and this oil. 1.62. In all is all contained what? That means in all contained in one medium. They said all of them are in one medium. Now, if an object is placed at the bottom of the what of the glass block, that means place an object here. Okay. Calculate the apparent position of the object from below. That means we are calculating the displacement from the bottom. And the displacement, don't forget, N is what? The refractive index. But whenever they are asking to find displacement from the bottom, it means what? The total displacement. A total displacement is what? G1 plus G2 plus what? G3. Or better still, we have our total thickness. What total thickness? 8 plus 6 plus 10. That will give us 24. Then we can use total thickness minus total displacement equal to thickness of oil over N of oil plus thickness of water over N of water plus thickness of glass block over N of glass. So what we want to do is what we are looking for, total displacement. So we have this one as 24 minus D that we are looking for. So this one now be what? 8 divided by 1.48 plus 6 divided by 1.33 plus 10 divided by 1.62. So when you do your calculation, so this one give us what? Plus 6 divided by 1.33 plus 10 divided by what? 1.62. So everything give us 16.808 what? 95. So equal to what? 24 minus displacement from the bottom, from below. So what do we have now? D we now to make implies that D becomes what? This one come here, this one come here. And 24 minus 16.08 16.95. So what we have, 24 minus 16.8, that's 7.91. So our answer is 7.91. So what I will do for you now is to try this one. Consider water on top of flint glass of thickness. So I will go straight to the question. Thickness of what? Of glass is what? 8 centimeter. And refractive index of glass, sorry, this one is T. And refractive index of glass is 1.44. Resting on top of crown glass. So T crown is what? 6 centimeter thick. And refractive index of crown glass is what?